In this video, we're going to try and find some derivatives. The first derivative that we want to find is for the function f of x, which is x squared minus 2x. Now remember, when I try and find my derivative, I'm actually using my gradient, my average gradient formula, but with the limit as h tends to 0, because I'm finding the gradient of the tangent at a single specific point on my curve. The first step in finding this is to find f of x plus h. Now remember, if I want to do this, I need to remember that everywhere there had been an x on my original expression, I need to replace it with my new variable, which is going to be x plus h. So doing this, I'm going to get that my function looks like this. I write the derivative. I know at the moment I still have a 0 in my denominator, and f of x plus h is going to be, instead of x squared, I write x plus h squared. And instead of minus 2 times x, I write minus 2 times x plus h. In the second part, I need to just put in the function f of x, but you need to remember that there were two terms in f of x, so the minus is going to be distributed to both terms. In other words, you must put a bracket around the whole expression. And this is all over h. You can see that I can only progress if I try and find my simplified numerator. So the derivative of the function as h tends to 0 is going to be x squared plus 2xh plus h squared. Distributing the minus 2, I get minus 2x minus 2h, and then in the last bracket, distributing the minus, I get minus x squared plus 2x, still all over h. Now you can see that there's some terms that I can add. If I take x squared and I add minus x squared, they add up to 0, as do minus 2x and 2x. Looking at the terms that I have left behind, I should be able to notice that I have a highest common factor of h. So taking out this highest common factor, I have h into 2x plus h minus 2. Now this h in the numerator can cancel that problematic h in my denominator. And when I cancel them, you will find that I no longer have a 0 denominator. So at this stage, I'm able to substitute any h value for 0. So the derivative is going to be 2x plus 0 minus 2. And simplified, that's going to be 2x minus 2. What that means is, if I'd wanted to find the gradient of a tangent at any point on my curve, I would have had to substitute the x value into this new expression, and I would have got the exact gradient of that tangent.